Let us now talk about logic gates. Logic gates are like simple electrical circuits, and these logic gates can be found in different digital devices that we use. And in actuality, this is how logic gates look like. Okay. By the way, this photo is not mine. I just grabbed it from Google Images. So this one is a one logic gate, another type, and another type of logic gate, and they function differently um, based on their designs. Now we will not discuss what's inside a logic gate, but we will discuss how logic gates work. Okay, so there are three primary or simplest logic gates. We have AND gate. I usually say it as AND gate, OR gate, and a NOT gate. Okay, so let's see how each one works. Let's start with an AND gate. Okay, an AND gate works. By the way, let's look at its circuit symbol first. Looking at its circuit symbol, it has two inputs and one output. We will always look for the output. An AND gate will have an output of on if both of the inputs are on. Okay, so let's make a truth table. This is what we call a truth table for an AND gate. Let's set input 1, 0 and input 2, 0. What will be our output? Our output will be 0. By the way, we use 0 for voltages which are low voltage. And then 1, we use that to indicate high voltage. Or 0 means off, 1 means on. Okay, so for an AND gate, it will only have an output of 1 if both inputs are on. So it makes sense because the word is from the word "and" in the English language. When we use "and," it means both. Okay, what if our input 1 is 0, input 2 is 1? Our output will be 0 because the inputs are not both on. So same thing with input 1, 1, input 2, 0, output will be 0. Then let's have input 1, 1, input 2, 1. What will be the output? The output will be 1 because both of the inputs are 1 or both inputs are turned on. So this is the truth table for an AND gate. Remember the symbol. Next gate is OR gate. So look at how an OR gate looks like. It also has two inputs and one output. So how does an OR gate work? Do you think it works like an AND gate? Okay, an OR gate, just like in English language, an OR gate will give an output of 1 or on if either of the inputs is on. Okay, so output will be on. Okay, so if input 1 is 0, input 2 is 0, output is 0 because neither of the two inputs are on. What if input 1 is 0, input 2 is 1? What will be the output? The output will be 1 because one of the inputs is 1. So if input 1 is 1, input 2 is 0, output will also be 1. Now what if input 1 is 1, input 2 is 1? The output is 1 because either of the one, at least one is turned on. Okay? But later I'll just mention that later. We have an exclusive OR. Okay, I'll just copy this. Okay, we have a SOR gate. What is a SOR gate? It is an exclusive OR gate, meaning, wait, I cannot move this. Okay, exclusive OR gate, meaning it will only be turned on if either one of the inputs are on, but not both. Okay, so let's do the truth table for an exclusive OR gate. 0, 0, 0, 0, 1 is 1 also because at least one of them is turned on, so output will be on. Either is on, so it's on. But what if it's both? If it's both, the output will be 0 because it's exclusive or exclusively either. Okay? Let's move on to NOT gate. NOT gate is just opposite. Just like in the English language, if it's not, it's the opposite. And this is how the circuit symbol looks like for a NOT gate. Only one input and then one output. Look at the diagram. This circle means not. Okay, so if it's not, it's just the opposite. So if our input is 0, output will be 1. If the input is 1, output is 0. Okay, that's how it works. Here, these are combinations of two logic gates. An AND gate, two inputs for an AND gate. It has one output, and this output of the AND gate is the input of a NOT gate. So let's make the truth table for this. So what can you expect the truth table for this? This will be the opposite of AND because it's not AND. Okay? And not. Okay? So input is 0, input 1, 0, input 2, 0. If it's an AND gate, output is 0. But it's not AND gate, so output is 1. Input 1, 0, input 2, 1. If it's an AND gate, 0, 1, AND gate here will be 0, but it's not, so it is 1. Okay, input 1, 1, input 2, 0, so this is 1, this is 0, AND gate output will be 0, and then it will go through a NOT gate, output will be 1. What if both inputs are 1? Input 1, 1, passing through AND gate, output will be 1, and then it will go through the NOT gate, so the opposite is 0. Okay? Next, NOT AND. A NOT gate, the output of a NOT gate is an input of an AND gate. Okay? Let's have, this is input 1, input 2. Let's have input 1, 0, input 2, 0. Input 1, 0, it will go through here, NOT gate, so it's 1. 1, and then 0, AND gate, so output is 0. I hope you were able to follow that. Let's do input 1, 1, input 2, 0. Input 1 goes through NOT gate, so it will be 0, 0, and 0 goes through AND gate, it is 0. Input 1, 0, input 2, 1. Input 1, 0, but it will go through NOT, 0, NOT, so it's 1. 1, and input 2, 1 goes through AND gate, so the output is 1. What if it's both 1? Input 1 is 1, go through NOT, so this is 0, 0, and then 1, AND gate, so this is 0. Okay, so here, NOT gate connected to an AND gate in the previous slide, an AND gate connected to a NOT gate. Okay, this one, NOR. It's already a combination of OR and NOT, not OR. So the truth table for a NOR is the opposite for an OR. Okay, let's have the truth table for 0, 0. 0, 0, if it's an OR, is 0, but it's not, it's 1. Okay, 0, 1. 0, 1, if it's an OR, it's 1, but it's not, so it's 0. 1, 0. 1, 0. 1, 0, if it's an OR, is 1, but it's not, so it is 0. What if we have 1, 1? 1, 1, if it's an OR, is 1, but it's not, so it's 0. Okay, so again, NOR is not OR, opposite of the truth table for OR. Okay, same thing happens with NAND gate. I don't have the slide for a NAND gate, but just remember for a NAND gate, it is NOT AND gate or opposite of AND gate. How will the circuit symbol look like? The circuit symbol will look like an AND gate with a circle at the end. Look at this. OR gate with a circle here is not NOR. So this circle symbol is representative of a NOT gate. So a NAND gate will look like an AND gate with a circle on the output. Okay? So let's try answering these questions. If you want, you can pause your video and then try answering this first on your own. Okay, but let me try discussing this. Logic gates are often used in electronic control circuits. The operation of a logic gate can be represented by a truth table. What logic gate is represented by the truth table shown? Write a sentence to describe its operation. Let's see. Input 1, 0, 0, 0. 1, 0, 0. 0, 1, 0. 1, 1, 1. So what logic gate is this? This is an AND gate. How can we describe its operation? Its operation is that it will give an output of 1 when both inputs are 1. Okay, letter B, try doing this on your own, and then when we meet again, we will discuss this. The output of a gate called an exclusive OR gate is on if just one of its two inputs is on. Otherwise, it is off. Draw a truth table to represent this. I think we already did this, right? Exclusive OR. Here's the exclusive OR. If only two inputs are 1 or on, the output is on. Otherwise, this is otherwise, the output is off. So this is the truth table for an exclusive OR gate. Next question. Name the two logic gates shown in the diagram. Okay, so this is an AND gate. This is a NOT gate. What will be the output of the combination of gates shown in the diagram if both inputs are on? Let's see. This is an AND gate, on, AND gate, it will be on. But it will go through a NOT gate, so the output is of. For this one, I will not read this anymore, but you pause your video, answer this in your notebook, and then we will discuss when we meet again. If you have your textbook, you can also find this at the end of chapter questions for chapter 19. I think this is the last question. Okay, try answering this and then we will discuss this together. If you have any questions, just write your questions in the Google document that I'll be posting in our Google Classroom.